Awesome. Thank you very much, ScotlandJS. As introduced, my name is Evan Morikawa. And this afternoon, I'm going to be talking about JavaScript taking the desktop. JavaScript is on the desktop, and that transition is well underway. You likely already use an application powered by JavaScript, and increasingly more every single day. So to start us off, I first want to give a little bit of background about why I'm even talking about the desktop, then show you a little bit about how it works, and finally, what you can do with it. So when I talk about the desktop, really I mean the place where you have a keyboard and a mouse and a 23 to 30-inch display. It's a place that's significant still today because overwhelmingly it is where real work is still getting done. It is where people are spending 8 to 10 hours a day in front of their computers doing work, and it has been drastically underserved by application developers and this community for a long time. But we do sort of build on this environment, right? We've been building in browsers for a while. So why do anything else outside of the browser? Well, there are a handful of things that you can't really get in the browser. Some of them is just a place that exists in a person's productivity flow, from being actually in the dock to the start menu to being alongside other applications that people are used to using all day long. But there are a lot of other more subtle pieces of interaction that really help users take your application to another level. And these are things like really working well offline, which is something that everything here people certainly expect to use, from being able to interact with a lot of the native pieces of all the different operating systems, and particularly working well on a Windows environment, because this is where a huge majority of the business world is, and also poorly neglected as well. So the desktop has had a very long history, right? It is sort of the original revolution of putting these computing devices in front of you. But the application frameworks on them have been pretty stagnant for quite a while. There are lots of traditional ways to build desktop applications, compiled languages, C++, a lot of the types of frameworks that you had to build on top of that too. These have a variety of issues, one being that likely a majority of this audience has never touched or played with them before, but also a lot of the issues that it takes to have your application run on all these different platforms. Why build an application that only works for Mac people and neglecting the entire Windows-using business world, or only run on certain flavors of Linux? So we've had this dream of the web on the desktop for actually a while as well. Node WebKit was an early project that attempted to, and is still very much going, to take what is basically a web browser frame, just a WebKit installation, and drop it into a frameless border that you could have a certain amount of control over. That actually was pretty good, but it still lacks some of those subtleties that help these applications cross what I call this uncanny valley, right? This place where if you right-click some of them, you get back and reload, which really makes no sense, especially if you're a right-click heavy Windows user. Plus being able to integrate with a lot of the native system pieces that all other applications have been able to do. So these are some of the issues with Node WebKit, and about 2 years ago, the GitHub team took one of the original creators from WebKit and started working on their own text editor, Atom, that was designed to be a desktop text editor built in modern web technology that was hackable to its core. And from that, they created this project called Atom Shell, which about 6 months ago got rebranded to Electron. An Electron is the core of what makes a large part of this new age of JavaScript-based desktop application building really possible, and one that makes that experience feel native and can help us cross that uncanny valley of being just a web page sitting on your desktop. So at a very high level, Electron is basically Chrome latest Chromium and Node.js strapped together into a runtime environment that I'll go into a little bit more shortly. But just to sort of show you what that gives you the capacity of, this is the project I've been working on. It's called N1. It is an open source extensible email client all built in Electron. And it behaves like you would expect a modern email client to be able to archive and snooze mail. But at the end of the day, this whole system is built with HTML, CSS, and JavaScript. This is all rendered with DOM, specifically with React, and has everything you'd expect from a web environment. But because of the injection of Node.js into this, not only do I have all of your standard DOM methods you're familiar with, but I have all of Node.js right here in the console as well, which combined together let you do a large number of particularly powerful things to make a much nicer development environment, a much more powerful one at that. To show you a little bit to understand more about how Electron works, let me first talk about what Chromium does, the browser you hopefully are all familiar with, Chrome. So when Chromium starts up, they have this entity they call the browser, the back-end process. It's what manages the application. And in Chromium, that is a large glob of C++ code that most of them in this room probably don't particularly want to dive into and play with. But from there, what Chromium does is that it has individual renderer processes, better known as tabs. But they're all process isolated from each other. They have their own runtime environment, and just sort of the DOM APIs you'd expect. Well, what Electron did is they replaced all of these pieces with Node.js, and also put a Node.js runtime in each and every single renderer process as well. This means if you want to boot up your own app, like the email client I've been working on, your entry point is a JavaScript file that you write. And from there, you get an API, in this case, Electron calls it browser window, to boot up your own window. You have full window control from your own JavaScript environment, which is a very powerful concept to have when you're managing Windows, and something that Node WebKit did not have in the very beginning. And from there, that browser window, just a Chrome tab with this runtime comes in and loads a plain old index.html. That entire email client is just a single page application with a couple more things on it, but it does boot from a single index.html and a single index.js file. And in our case, we're using React to render everything, but at that point, it's up to you however you want to put stuff onto the page. The big difference is that we're not confined to this one tab. We also have then the capacity to spawn additional windows, which we use for the composers, the pop-out email composers that we have, or for these worker window pieces that I'll show shortly as well. And when you pull all that together, you can then boot these applications all with JavaScript, and all just by loading environments that you're already familiar with. So to sort of go over a little bit more about what this really gives you, I want to first talk about the type of native feeling experience that you can get with the Electron APIs and with a little bit of styling that you can't really elsewhere. So one big piece about what I mean when I say feeling native has to do with things like that right-click menu issue I talked about earlier. Right, Electron gives you the APIs to override a right-click. So in our case, we want to reply and forward to an email, archive, trash it, snooze it. But it also means you can add pieces directly into the toolbar here. In our case, we use it to create a new message. But I have seen applications that exist in nothing but that toolbar that have actually no major UI component to it at all. And it also means integrating with pieces like the native notification system and doing so across all platforms. So you could, right from the console, display a notification that comes up in the native Mac notification system, is there in your dock, and crucially is also something that works on Windows as well in the places that Windows users expect them to have. The combination of a lot of these little APIs is sort of what I'm getting at about these niceties, these experiences that people expect, and just something feels off when they're not quite there. In addition to the Electron APIs, you have everything that latest Chromium has. The most recent version of Electron is Chrome 51 and Node 6. So if you can think of it in Chrome and it works in Chrome 51, it will work here. And the other big piece about this experience is just the UI pieces as well. So the UI is actually all rendered in CSS. And there are a lot of existing projects to help you get all of these details right. We started this app a little bit before some of these projects took off, so we did manage a lot of the details ourselves. On Mac, these buttons, for example, it was a bit careful to just get the gradients right and to make sure that everything looks properly. But because we're only supporting one environment, if it works and looks properly in latest Chrome in Electron, you're done. There's no cross-browser compatibility issues, which is one of the biggest pains of CSS. It means we can do fun tricks like these buttons here on a Mac's Retina display are a true half-pixel border, and whereas on non-Retina displays, they're a full pixel. And you can cheat that by giving them these half-pixel box shadows you can give them by these little half-pixel box shadows to emulate those border contexts as well. We even, in our case, emulate the stoplight icons, which actually is not necessary because Electron comes with these bars, but it gives you the control to sort of put them wherever you want. Supporting Windows, we also do with CSS as well, actually through just a whole body level class. So you're looking at what it looks like on Mac, but if I change this to Windows, now these are all the buttons that you would experience using the latest Windows 10 UI and getting sort of the transitions and the easing of their button specs on the application. So there's an enormous amount of control that you can have. In our case, we definitely went towards the end of rolling a lot of it ourselves. A lot of these components, there's now a huge library of pre-made components that adhere to all of these specs that you can just drop in the classes for. So summing up a lot of these different techniques, be it visual styles, be it these more native APIs, really helps make this native feeling experience. It's something that exists on the dock, something that exists in all of your toolbars, and hopefully makes people not even realize that they're using an application built on web technology while still getting advantage of all the tooling that we have. Speaking of tooling, that's what it leads me to performance. Performance also always comes up when people think about using a web environment on desktop. They're like, oh, why don't you just write your own C++ code to do that? You could probably do that faster. And frankly, for certain very optimized routines, you probably could write a faster C++ program. But when it comes to, at the end of the day, a user experience, performance is actually something we're all used to as web developers. Performance optimization on Electron is exactly the same as all the good practice techniques you see on the web. We very heavily make use of the Chrome inspector tools to make sure everything is painting at 60 frames per second. And at the end of the day, if it paints and renders at 60 frames per second, no users will care what it's written in. The big difference and advantage here is that the Chrome profiler tools are unbelievably nice. Being able to see that type of render performance, the paint layers, the keyframes, and the flame charts and all of these pieces is an enormous boost to your productivity in being able to make an application that runs really smoothly. Not to mention that every day the Chromium and Node teams make huge strides to make that whole system faster. You actually have an entire performance team funded by Google helping make this run increasingly quickly. And I'm really happy that there were talks about service workers because a lot of these experimental technologies, like I said, if you can use them in Chrome 51, they will work here as well. Electron does, however, give you a couple extra leg ups in addition to web workers and service workers, and a trick that we use heavily. You heard pretty extensively about what happens when a lot of data comes down in processing. Well, we discovered that when you try and sync and JSONify and stringify potentially gigabytes of email data, it has some serious issues janking your render frames. So as a result, what we can do with Electron is load another window. This is a window whose only job is to process background tasks. And it is an entirely separate Chrome process. It is truly running in parallel from everything else. But unlike a service worker web worker, we can also throw a UI on top of it as well, because it's just another rendering environment. The two windows can talk to each other through IPC. There's that backend process that can manage all the information there. And in our case, we have this processing all of the data in the background, and it frees up this whole front end from working, from having to deal with all of that. It's also particularly nice in this case that we can render a UI component on it. There are a lot of issues with web workers where not having a context environment makes some issues with text resizing, for example, in React not work properly fully in a web worker. But with Electron, with these window and process controls, you can get around that and render it all yourself. So by the time you sum up a lot of these performance optimizations, like I said, largely many of which come from the standard web world in general, you absolutely can make an application that runs as performantly as anything else that exists on your dock, arguably more performantly than some. And as a result, we have the ability to create these applications that feel as smooth to users as what they're used to, with the advantage of all the profiling tools and tooling ecosystem that exists for the JavaScript world. Another great advantage of the Electron environment is access to the file system and what that gives you in terms of offline performance as well. This worker window also uses a queuing system. So if you go offline, all of the actions you take, you're archiving your messages or whatever, all get queued up. But we can persist those to the file system. So if you quit the app and relaunch it again, we can reinflate everything from the file system and keep on going. If you drop network connection or on the airplane for a while, we can queue those up and synchronize them back when you come back online and be able to robustly back everything from the file system. And which is really important when we start thinking about data, especially on the scale of an entire inbox across all of your inboxes. The very first version of this, we tried WebSQL, we tried some of the local storage on steroids, but really because you have this Electron environment, you have file system access and process control, we actually ended up compiling a local SQLite instance to back this application with. This means that the whole thing has direct access to a SQL database. So if I want to load all the contacts, I can fire a request from any window that hit an actual SQL database that's indexed and has full text search enabled, and in this case returned, this was a dumb query, but all 33,000 contacts pretty immediately too. This leads to some very interesting patterns you can do once you have a database that is not accessible on a server, but just right there. One of the big things we take advantage of with that is observables. And I'm particularly happy that Matt was here yesterday because ReactiveX and sort of this observable pattern is extremely powerful when you have this sort of database environment right here. In our case, what we do is we basically hook up queries straight to the database and use observables to render everything. So to show that looks like slightly more concretely, this is an example of a piece of code we have all over the place. In this case, I would say I want to render all of the current list of email threads. Well, that can change all the time. That changes based on the view you're looking at, when new data comes in, when plugins update it and change it. And the way you set it up here is you say, I want to declare that anything that matches that query, no matter when it comes in or how, I set this up once, and all of that data drops straight into my React components. It calls setState on React as that event updates, and it continuously displays what's in the database. Though these type of live queries are increasingly popular on server environments, but now in Electron, you can hook them straight up to view systems. In addition, like Matt was showing yesterday, one of the most powerful things about this is you can subsequently chain these filter and map operations on top of this. You can really treat it like a pipeline of data, which means that in a really constantly changing world, when everything continuously updates, it's a very robust way to think about how to connect data sources, in our case a database, straight to your view components. The final major piece that we very heavily use Electron for is the ability to support this plugin ecosystem and support a lot of extensibility on top of that as well. This is one of the main reasons Atom was there, was to support their plugin ecosystem on top of that. And we've been doing a very similar concept, but with email. So one of the biggest reasons why we built N1 in the first place was to be able to build an email client that could support a bunch of additional plugins, one that adds emoji or scheduling or mail merge or link tracking or translations. It means that at the end of the day, I can write myself an email and use a system that, say, integrates with my existing calendar to sort of to schedule times that you would want to meet up for coffee or something like that. And then be able to translate and send all of these on the fly and send them later. These are the types of plugin systems that we can combine together because we can load all of these individual plugins from disk. They can be installed, we can uninstall them, we load them from disk, and render them onto the page at runtime. And this is actually a combination of being able to have file system access through Electron, but also a property of the way we've built this plugin system based all on React. Everything you see on this, in this client is an individual plugin backed by a React component. And what we've done is we've built in these regions that you can register components to drop in place for. So here, if I want anything to show up in this sidebar, I can just register a React component, drop it in there, and it will render accordingly. This is a much nicer way to build a plugin system, because if you remember Chrome extensions, you sort of reach into the DOM with jQuery and kind of hope for the best, which is partly why it's very difficult to run a lot of different plugins in the same environment as once. But because we can load them from disk, we can inject them through these React regions, it's a much nicer way to maintain these systems when you might have dozens of plugins loading to enhance and to sort of customize email to be whatever experience you want at any given time. And the plugins are a big piece for at least why we came into this too. But at the end of the day, it's also a very good way to think about building this application in a very extensible way. It forces us to think about all these different components as their own mini pieces that can get injected anywhere they want, with the added benefit that we can do it from disk and we have all of the capabilities that Electron provides in order to move them all in together. I should also mention that the email client is all open source. Open source is a big piece about what we're all about, and directly benefited from Atom open sourcing their project too. Some of these patterns exist in the Electron community, but some of them are also new. So hopefully this can continue to serve as a reference application for building a lot of these larger scale things with Electron in a very much ongoing and active project. This is a project that we have open source and something that can be downloaded today and run as well. If that loads, I guess not. Yeah, I also want to finally close up by saying that this is not just the effort of myself. This certainly took a team of us in San Francisco to put together that I'm very much indebted to as well. And finally, I want to leave you with hopefully an interest to at least go and play with this development environment. I will say, on just a day-to-day level, not needing to support other browsers, being able to use the latest technology you want, and also packaging it in this first-class application way has just been an absolute joy to use. If anything, it's a fun sandbox and development environment But as our client, and hopefully a lot of other companies are increasingly showing, is very much going to be the bedrock for a lot of very large applications out there, from R's to Slacks to Visual Studio Code to Atom and many more along the way. It's a pretty exciting time for desktop environments, and I actually think that as a result of tools like this, because it is so much easier to build, we hopefully will see more specialized applications that are more powerful that you will be using every day, as long as we have keyboards and large screens that we want to look at. Thank you very much.